Hello everyone, welcome to the channel, welcome to the learning field. So this is the lecture series for the solution of GATE just a second, GATE 2018 LPP paper. Okay, so this is the solution video of GATE 2018 LPP paper. Okay, so if the content is helpful, then please give a like to this video, share with your friends and subscribe the channel. And the GATE playlist, that is the LPP, the theory part of LPP for the GATE exam, CSIR NET exam and any state level set exam, complete lecture series of GATE LPP is available in the channel. Okay, so you can see the and you can watch the playlist of or the videos of LPP. Okay, so and one more thing is that the previous year of the GATE exam, GATE 2022, 2021, 2020, 2019 are also the solution of this paper are already available in the channel. So you can check the playlist GATE mathematics and also check the playlist LPP for what LPP for the GATE, CSIR NET and SET exam. Okay, so which is this playlist. Okay, so let us start to solve the questions. And one more thing is that in GATE 2018, okay, so in GATE 2018 there are 3 questions comes from LPP. Okay, one is from 1 marks and 2 questions are of 2 marks. Therefore total 5 marks comes in GATE 2018. Okay, so let's start. So question number 14, which is a 1 mark question, it says that what for the linear programming problem, which one of the following statement is false? Okay, which one of the following statements is false? Now if we did the options, okay, so the options are: if a constant is equality, then the corresponding dual variable is unrestricted in sign. Yes, this is true statement. We all know that this is the true statement. Okay, if the primal problem has an equality constant, then the dual problem corresponding dual variable has the dual variable is unrestricted in sign. Okay, so this is true statement, therefore this is not the false statement. Okay, both the primal and its dual can be invisible. Yes, it can be invisible because there are 2 situations occurred in this case. So if the primal problem is infeasible, then the dual is either unbounded solution or can have infeasible solution. Okay, so these are 2 cases, therefore both primal and dual, its dual can be infeasible. This is also the true statement and therefore this is not the false option. If the primal is unbounded, then the dual is infeasible. Yes, this is the case. Primal is infeasible, then dual may be infeasible or unbounded its solution. This is also the true statement. The next statement, so this is not our answer. Next, the option D says that even if both primal and dual are feasible, the optimal values of the primal and dual can differ. So this is not the correct option. By fundamental theorem of LPP, we know that what if the primal problem has feasible, has optimal solution, then the dual is also the optimal solution, and the optimal value of the primal problem and dual problem are same. Okay, so this is the fundamental theorem of LPP. You can fundamental theorem of duality, you can say fundamental theorem of duality. So this statement violates the fundamental theorem of duality. Okay, so therefore this is not the correct statement. So this is our required answer. Okay, so the correct option is option number D. Even if both the primal or dual are feasible, the optimal values of the primal and dual can differ. This is our required answer. Okay, now we are going to the next question. The next question, question number 39 of the question paper. This is a 2 mark question. Okay, the question says that consider the linear programming problem, maximize alpha x1 plus x2 subject to 2x1 plus x2 less equal to 6 minus x1 plus x2 less equal to 1 and x1 plus x2 less equal to 4. Okay, so this is a standard LPP problem. Okay, maximization problem with less equal to type constant. So this is a maximization problem, simple standard LPP. Okay, where alpha is a constant, if 30 is the only the optimal solution, then the value of alpha, range of the value of alpha. Okay, so this is basically standard questions from GATE. This type of questions are asked in the previous year GATE exam, that is 2022. लास्ट जो हम लोग यहाँ पे ईयर्स को सॉल्व किया, तो उसमें भी इस टाइप का क्वेश्चन आया था. ठीक है, तो यू कैन चेक इट वंस. सो फर्स्ट वी find its dual. Okay, so the dual of the problem, suppose dual variables are y1, y2, y3, therefore the dual is minimize, suppose w equal to 6 y1 plus y2 plus 4 y3. Okay, subject to the constant what, subject to this 2 y1 minus y2 plus y3, which is greater or equal to alpha, and the next one is y1 plus y2 plus y3, y1 plus y2 plus y3, which is greater or equal to 1. Okay, so these are the two constants of the dual problem. Okay, now it is given that 3 0 is the only optimal solution. So if we put the value to the maximization problem, the optimal function, objective function, what, objective function is what, the value of objective function is 3 into alpha plus 0, so this is equal to 3 alpha. Okay, so the objective value is 3 alpha. Now we put this optimal solution, now we apply what, now we apply the complementary slackness theorem. Okay, so this theorem is very important for GATE LPB. Okay, complementary slackness theorem. So complementary slackness theorem says that if strict inequality occurs in the optimal solution of its the primal problem, for the primal problem, then the corresponding dual variable is 0. That means what, we put this 3 0 is the optimal solution, it is given, so we put this 3 0 value to the constant and check whether the constant follows strict inequality or not. If it is it follows strict inequality, then corresponding dual variable is 0. Okay, so we first put the value to the first constant 2 into 3 plus 0, which is equal to 6, which is not the strict inequality, so this goes to this is not our needed. Okay, so next one is minus x1, so minus 3 plus 0, which is strictly less than 1, therefore this follows the strict inequality. Okay, this constant follows the strict inequality. That means what, that means the corresponding dual variable is 0. The corresponding dual variable means what, this is the second inequality, therefore the corresponding dual variables means the y2, so this is equal to 0 by the complementary slackness theorem. Now we put the values, this 3 0 to the third constant. Okay, so 3 0 equal to, so if we put the value, so 3 plus 0 which is equal to 3, which is strictly less than 4. Okay, so this is also follows the strict inequality, that is the third constant. This implies what, this implies the third constant of the dual third variable of the dual is also 0. Okay, so the max objective function of the dual is reduces to what, minimum of w, this is equal to 6 y1 only. So this is the value of the objective function of the corresponding dual problem. Okay, now we put the values y1 of y1 and y2 to this constant. Okay, so now we get, if we put the value y1, we don't know the value of y1, and y2 equal to 0 and y3 equal to 0 to the first constant, then from this constant we get what, 2 y1 is greater or equal to what, alpha. Okay, so 2 y1 is greater or equal to alpha we get, and if we put it to the second constant, then this gives y1 is greater or equal to 1. Okay, so we get y1 is greater or equal to 1. Just a minute. Okay, sorry, 2y1 not, this is the 6y1. Okay, sorry, minimum of w equal to 6y1, I think, yes, it is 6y1. Okay, so it is not needed, so this first concept is not needed. You can check it. Okay, you can write it. Now the value of y1 should be greater or equal to 1. Now we have to minimize this objective function, which is included only dual variable is what, the only dual variable is y2. Okay, so the only dual variable is y2, that is we have to minimize this w equal to just 6y1. Just a minute, we have to minimize, this is equal to 6y1, and we know that this value of y1 is greater or equal to what, 1. Okay, so the value of y1 is greater or equal to 1. If we minimize and we get, this is the lowest value of y1, that is 1 is the lowest value of y1. So if we and the value of y is greater than 1, therefore the minimum value of the objective function is what? This is 6 into 1. Since y at y equal to 1, this gives the minimum value, therefore, and we have to minimize this objective function, therefore the minimum value of the dual is what? This is 6. Okay, now I think it is clear. Okay, if you don't understand, then you can comment me in the comment section below. Okay, so now this is given. Now the we know we apply the what? We apply the weak duality theorem. Now we apply the weak duality theorem. So this question is easy, but 2 or 3 theorem is needed. Okay, so weak duality theorem says that what? The minimization problem which is greater or equal to the maximization for any case, whether this is case of primal or dual. Okay, you always remind that the minimization is greater or equal to always maximization, whether it is the what, primal or dual. Okay, so you remind this one, this line. Okay, so what the value of now the objective function of the this value, that is this is minimum, so this is equal to 6, and the objective function, that is maximization problem, this is what? This is the value is this 3 alpha. This is the value in case of primal problem. Okay, so 6 is greater or equal to 3 alpha. Okay, that means what? That means sorry, our answer is sorry, this is less than 6 is the 6 is less equal to just a minute. You can, so this now this implies 6 is less equal to what? 3 alpha. Okay, so this implies alpha is greater or equal to 2. Okay, so the correct answer is option D. Okay, the correct answer is option D, alpha is greater than 2. Now we go to the next problem, question number 55. This is question says that a certain commodity is produced by the manufacturing plants P1 and P2 whose capacities are 6 and 5 units respectively. The commodity is shipped to the market M1 and M2 and M3 and M4 whose requirements are 1, 2, 3 and 5 units respectively. The transportation cost per unit from the market Pi to the market Mj is as follows. This one, so this is the transportation problem. The optimal cost of the transportation is needed. Okay, so this is a transportation problem. So first, in case of transportation problem, we first apply the northwest corner method. Okay, northwest corner method. Now we apply the northwest corner method, or you can apply the matrix minima method. Okay, you can also apply matrix minima method. So we apply the matrix minima method, then we get, or we can apply also the northwest corner method. The cost are 1, 3, 5 and 8. This is 6, this is 5 and 2, 5, 6, 7, 2, 5, 6, 7, 1, 2, 3 and 5. So if we apply the northwest corner method, then we see that, so this is the north and west first, so this is the cell, so we allocate the minimum value of 6 and 1, so this is equal to 1, so this is exhausted and their remaining is 5 unit. Okay, now if we go to the next one, so this is the next northwest cell, so if we apply, so this is the minimum of this 2 and this 5, so this is equal to 2, therefore this is exhausted and here 3 units remaining. Okay, the next northwest cell is this one, and we write here the minimum of this 3 and this 3, which is equal to 3, this is exhausted, this is exhausted, and here only 5 units. Okay, so this is the northwest corner method. Okay, now we see that the number of cell allocation. Okay, so number of cell allocation is 1, 2, 3 and 4. Okay, so number of cell allocation here is 4, and we know that the maximum number of cell allocation is m plus n minus 1. So m means the number of rows, n means the number of columns. Okay, here or order of the matrix, m is here 4 cross 2 matrix, 4 by 2 matrix. So this is equal to 4 plus 2 minus 1, this is equal to what, 5. Okay, but there is the number of cell allocation is 4. Okay, just a minute. Okay, so this is the minimum, this is equal to what, this is equal to 4 plus 2 minus 1, so this is equal to 5. So in this case the optimality condition is satisfied, but there are two cases. Okay, all you can if you can check the delta ij, which is equal to ui plus vj minus c ij, you can check it, but this is the we don't go to this process, this is a very long process. We just go to the northwest corner method and check once if you can apply also the matrix minima method. Okay, so if we check, we see that all delta ij is greater or equal to 0, you can check that obviously, and this is greater less equal to so this 4 is less equal to 5. Therefore we can say that the system, that is this transportation problem, has what, degenerate solution. Okay, the transportation problem has degenerate solution. You can also apply matrix minima method. Now we just find the cost of this matrix. This is a very easy problem. Okay, so the minimum cost is, that is the optimal cost is 5 into 7 plus 3 into 5 plus 3 into 2 plus 1. Okay, so this is equal to 35 plus 15 plus 6 plus 1, which is equal to 57 units. Okay, therefore the optimal cost of the transportation problem is 57 units. Okay, you can go the complete procedure or the big procedure or the calculations, but you don't need to go this for this problem. Okay, so this is the 57 units is the correct answer. Okay, so this is the questions of GATE 2018. Okay, so this ends the classes. So if you like the content, then please give a like to this video, share with your friends and subscribe to the channel. Okay, thank you friends, see you again in the next video. Thank you.